Okay, so today we're going to do our quiz on 10.2 and 11.1, and then we're going to touch a little bit on 11.2. We're probably not going to get to 11.3. There's three things I'm going to tell you guys to break. Today, you have due 10.1 due today, and again, like I said, you have to use the table that is on the, that they give you in the program for one of the problems. So try it with our table. If that doesn't work, then use their table. Connect Math 10.2 and 11.1 are due on Tuesday. Those are pretty short. They should only take about half an hour each. And then Lab 10 is also due on Tuesday. You have to do it in Excel. Apparently one student did manage to do it in Sheets, but you got to figure it out on your own if you're going to do it in Sheets. So you have to do all the same things in Sheets, and it's on you to figure that out. Good. Next Thursday you have Connect Math 11.2 due, and then Sunday, the 15th, you have Connect Math 11.3 due. The final is going to be about 35% on chapters 10 and 11, and the rest about 20% on exam 1, 20% on exam 2 material, and 25% on exam 3 material. So then that leads to what should you study? This is what you should study. So for the final, this is your study guide for the final. Those problems from each of those study guides. Study guide exam 1 has 2 number 21s. It's the first one. This is also found on Canvas under study guides, exam study guides. I think it's under list of problems for final or something like that. Or problems to study for final or something like that. And if you click on that, it'll bring up this handout. Are there any questions about Lab 10? Everybody good to go on that one, or questions about it? Okay.
I'm still good.
Okay. Before I talk about this, Math Jam. If you have any friends who are taking statistics or calculus or trig or business calc or college algebra or any of the algebras, math. If you have anybody who's taking math next semester, encourage them to take Math Jam. It's free. It's the week before the semester starts, and you just work on problems to get you kind of ready for the semester, so you can kind of get a jump start on that one and feel very confident going in and crush it. And we also feed you. You get free food.
Yay!
So, and then Prep to Pass. Speaking of free food, Prep to Pass is next week, 6:30 to 9 o'clock on Tuesday and Wednesday of next week. It's going to be in the tutorial centers right around the corner. They'll have tutors there. And you can go in there to study with each other. And so before class, you guys have your little other stuff.
Oh, yeah.
But you stop in there and study in there for 10 minutes and get some pizza. Right?
That's smack dab in the middle of the class, though. 6:30 to 9?
6:30 to 9.
Yeah.
Yeah. So
We could leave at 7.
Oh,
after 15
yeah.
minutes. That would
Yeah.
work.
Yeah. So if you kind of stick out there at 7 and then say, we got to go get pizza.
Yeah.
And then go in there and study for a little bit and then come in here.
We'll tell them our teacher told us.
Right. But yeah, they usually have pizza and drinks and stuff like that there, and snacks. So, go there and study and load up on snacks before class. Okay. Let's talk about regression. So the regression line is the line of best fit that best fits the scatter plot of your data. Prashant, go ahead and read.
This line, the regression line, this line is used to predict the values of y for a given x, only when there is a correlation/relationship. When r is not significantly different from 0, the best predictor of y is the mean of the data values of y. If not aligned, use the average.
Right. So if you reject h naught, then you use that linear regression line. If you do not reject h naught, then use the average. Right? I think that makes sense to people.
Yeah.
Right? If your data is not correlated, like shoe size and grade on the last exam, do you think those are correlated?
No.
No, so what's my best guess for guessing at the the grade of somebody who has a size 4 shoe, the average, the class average. Make sense? Okay. So if they're not correlated, if you did not reject H naught, just use the average. If you did reject H naught, if there is a correlation, if it is a line, then use the linear regression line to predict. Here is the regression line. It's y prime equals a plus bx. X is your independent variable, y is your dependent variable. So x is the one you can mess with, that you can kind of change. And you can use the TI calculator and Lindreg t-test to find A and B. Lindreg t-test, right there. Abdullah, go ahead and read.
Exploration, future predictions. Use a regression equation for a prediction only if the linear correlation coefficient R indicates that there is a linear correlation between the two variables, and if the graph of the regression line on scatter plot confirms that the regression line fits the point reasonably well.
Keep going.
If your data is not correlated, R is close to 0, so no relationship. The best predicted value of a variable is its sample mean.
All right, so your data is not correlated, use the sample mean. So this is what we mean about in terms of the R. In other words, if we reject H naught, then it is a line. So then you're going to use y equals a plus bx. If you do not reject H naught, then it's not a line. Your best guess for y is y bar. And your best guess for x is x bar. Make sense?
Yes.
The other thing to consider is, if you look at your scatter plot, it will show you whether or not there's something else going on that you aren't aware of. Because sometimes you'll get fooled by one outlier or something else that's kind of going on. So that first one is kind of what you expect to see. But you might, if you end up with something like that, then you can clearly see, oh look, that's a curve, that's not a line. It's not linear. And then here, it shouldn't be this line, it should be a different line because it's that weird outlier. Same thing here, right? It's that weird outlier changing things around. But all four of those pictures have the same R, the same correlation coefficient, and the same linear line of regression. So you have to look at the graph to confirm. How do you do that? Let's see what I have in here. Yeah, that's okay. Okay, I can use these two. All right, so I'm going to do stat test, Lindreg t-test. Oops. Test, Lindreg t-test. I'm going to put L1 and L3. Frequency is always 1. The test is always not equal to. And this reg equate, you always leave that blank. You guys would normally have L1 and L2 in there, but I did something funny, so I did something different. It gives you a line of regression. And then, so it gives you my A and my B. So here my A is negative 7.218, and my B is 0.2615. Let's see what my R is. Oh, so my R is decent, 0.853. So if I want to graph these points, stat plot, and make sure you turn your plot on. So you click on one, and you can turn it on or off here. So if you go to on and turn it on, and then make sure this says scatter, and then put your x's in the list you have x's in. I have my y's in list 3, so I changed it a little bit. If you hit zoom 9, that's going to graph it for you. Zoom 9. And then if you want to graph your line of regression, hit y equals, and then you can type it in there. So mine was negative 7.218 plus 0.2615. And then how do I to get your x, you guys see this little button that says x, t, theta, n? Just hit it once and I'll give you an x. And then if I hit zoom 9 again, it'll graph the line in there too. And you say, okay, well that looks pretty reasonable, like that's fairly well correlated, and that seems like that might be reasonable. Good? You don't need to know that, it's just a little bit of added information, like just generally speaking in the world as you go out there and do statistics in the future in your lives, that's something to be kind of be aware of and how to do that. Okay. So let's take a look at your thing here. We rejected h naught, so can we use y equals a plus bx?
Yes.
Yes, y equals a plus bx. What'd you get for your a?
0.119.
0,
0.
And what would you get for your y? For your a?
Point 19.
Okay. And then what did you guys get for your b? What did you get for your b? Okay, so good. At least 3 sig figs. Gotcha, this should be one more sig fig then, so this should be a 3. Okay, good. Everybody on board? So then, here we're saying 5.2% drug. Is that my x or my y?
X.
It's my x. Okay, so now look at here and see how all my drugs are in percent? All these are percents. So it means that my x here would be 5.2. Wouldn't be 0.052, it would be 5.2. Everybody kind of follow?
Yes.
So all my data is already in percents. So here, I'm going to say, okay, if my x is 5.2, what's my y? So I'm going to throw in 5.2 into there, and you're going to get y equals what?
3.3.
3.332. So 3.33 or 3.3. Good?
Yes.
Go with that part? Okay, great. Now we're going to look at B, or 2. Here, we did not reject H naught. So can we use y equals a plus bx?
No.
No, we can't use it. Don't use that. Right? We did not reject H naught. So instead, we're going to use what?
Y bar. Samples.
Yeah, we're going to use the mean, sample mean. So here, 190,000 square feet in size. Is that my x or my y?
Your
I will look at x and y. Look at your x's and your y's. It is.
X.
Sorry. I will look up. See where it says 190,000 square feet? Is that my x or my y?
Yes.
My x. Everybody follow that?
Yes.
So look at your data. So this is 190 goes there. I need to find the y that goes with that.
Yes.
So my y, my best guess at y is what? The average y.
Yes. 1/3.
Y bar.
Yep.
Everybody take 30 seconds and find y bar. Can you find y bar?
Yes.
Do you have your y's in list somewhere? Hopefully you do. If not, put them in a list quickly. How do you find the average O list?
1 bar star.
Yep, stat calc 1 bar stats of whatever that list is. You can use your keyboard faster, I think. Here, I'll do it. Good. Stat, calc, 1 bar stats. I put mine in list 1, so second L1. I got an X bar of 134.7. It's going to say X bar no matter what. You know you put Y's in there. It's still going to call it X bar.
Yes.
So but you know it's really Y bar. Just put Y's in there. 134.7. All good? Okay. Great. Now, do lab problem 6. from start to finish. So that means do your whole, don't do a scatter plot, but do your step 1, your 5 steps, your hypothesis test, and then predict for 100 whatever fires, 100, I think it's 10,000, 100,000 fires or something like that.
100.